Welcome to Miskin in South Wales. Here is one of our manufacturing facilities where we undertake manufacture of components and the final assembly of those into final products. We acquired this site in 2011 and we've recently made significant investment in the factory space available and also manufacturing capacity. We're currently employing over 700 staff on this site. We're very proud of our manufacturing operation and we'd like to give you an insight into our organisation. What I'd like to point out is we are very much a manufacturer and face challenges like many of our customers in terms of productivity, automation and skills shortages. What I'd like to show you today is how we've addressed some of these problems and how we've used our own products in doing so. Having our own manufacturing facility has allowed us to test and develop our products and processes. For example, the Productive Process Pyramid and IPC software were tested and evolved in our own manufacturing facility before these were even concepts and products we shared with our customers. Most recently, we've been using our Renishaw Central product to help identify automation stoppages and improvement opportunities within our own processes. So, let us show you inside our factory, where some of my manufacturing colleagues can give you an insight into our processes.
Hall 2 here at Miskin is the location of one of our high-volume machine shops. I'm going to talk you through our RAMTIC process, which meets some of our high-volume milling requirements. The RAMTIC process here is where most of our high-volume milling requirements are met within the machine shop. It is based both at our Stonehouse site in Gloucestershire and here at Miskin at our component manufacturing site. RAMTIC stands for Renishaw Automated Milling, Turning and Inspection Centre. It is based around the standard milling centre from Mazak, the FJV250, with modifications using Renishaw probes and machine tool products. We have 65 RAMTIC machines across both of our component manufacturing sites. 44 of these run at a higher spindle speed of 20,000 RPM and primarily cut aluminium. The other 21 run at a slightly lower spindle speed of 12,000 RPM, primarily cutting stainless steel, although these do have the capability to cut polymer-based materials, aluminium and cast iron as well. The carousel consists of 50 slots. The first section is taken up by specially made fixtures which hold the tooling required. The second section is taken up by specially designed fixtures which hold the raw material and work-in-progress parts. We aim to use a standardised catalogue of tooling within our RAMTIC process, which are primarily manufactured in-house as well, using our cutter-grinder machines. The nature of the RAMTIC process means that it's very flexible and allows for agile scheduling. Where we have an increase in demand of a certain part, we can replicate product kits and make up additional carousels. The aluminium swarf, which is produced as a result of the RAMTIC process, is disposed of through an automated process as well. A conveyor system carries it along to a briquette machine where aluminium briquettes are formed so that we can dispose of it as high-value scrap. The process is set up using a pre-flight checklist. The operators follow this checklist to ensure the machine is set up as effectively as possible. This means that minimal stoppages will occur during the startup and throughout the machining process. During the setup process, the carousel is connected to the machine through compressed air and a power line. Once the carousel is connected and the machine is started up, the probes take over. The two OMP 400 probes are used for various elements of the startup procedure, as well as during the process. At the beginning of the process, the OMP 400 probes measure the position of the machine's core, the alignment of the fixtures, the position of the raw material within the fixture, and in addition to this, the probes also carry out in-cycle gauging. The parts are measured during the machining process to ensure dimensional accuracy. Once the probes have started the process, we then use machine tool products to datum the tooling. The tools are brought into the machine wing by wing and taken into the tool magazine by the spindle, bringing the tools over to the automatic tool changer. The tools are then datumed using either an NC4 or a TS27, dependent on the requirement and the type of tool. The NC4 and TS27 measure either the length, the radii, or the width of the tool. Any deviations found during the tool datuming or any of the probing elements of the process are fed back to the machine, and the machine compensates for these deviations by inputting offsets. The probes continue to operate throughout the process and carry out in-cycle gauging. At this point, the probe measures machined features of the part to ensure dimensional accuracy. Due to the nature of the RAMTIC process, the machines often operate unmanned and have very little downtime, approximately 30 minutes of downtime per 24 hours for each machine. This means that labour cost is low, with only 4 machine operators per shift across both sites running all 65 machines. The kitting work centre bookends the RAMTIC process. Once the machining process has been completed, the carousels are returned to the kitting stations where they can be prepared for the next machining process. Renishaw Central is the latest addition to the RAMTIC process in terms of process monitoring. Its primary application is as a diagnostic tool for the identification of machine stoppages. It provides opportunities to implement process improvements and reduce downtime as much as possible. RAMTIC was one of the testing grounds for Renishaw Central, and it has allowed us to further understand Renishaw Central's capabilities and how it might be implemented in other production facilities. We apply the pyramid approach to the RAMTIC process, making small adjustments where needed and having high confidence in part quality. RAMTIC's automation means that there's very little requirement for subsequent post-machining automation.
So I'm here at the RAMTIC Kitting Station. One of the fundamental parts of RAMTIC is the carousel. And what the carousel is essentially a mobile pallet system. And what we do is an offline pre-kit before it gets to the machine. And we load the carousel with all the tools, the fixtures and the materials required to run a job. These are kit onto dovetail fixtures that we call wings, and our carousel can be kit up with up to 50 wings to run a job. So this all happens away from the machine, so at the kitting station. This helps to increase spindle uptime, but also keeps production flexible, as once these carousels have been kit, they can be loaded onto any one of our RAMTIC milling machines, whichever one becomes available next. The first thing to mention that we kit at our kitting station is the tooling, and we use a standard set of cutting tools with a predictable life and process capability. And most of our cutting tools are actually made in-house, and we store information about these tools in a kitting database. That kitting database contains information regarding that tool build, so it'll contain all the tool's projection settings and also the estimated life of that cutting tool. In terms of materials, we use a Kanban bin system with a standard set of billet sizes, which we cut to length in-house on our saws. Generally on RAMTIC, we're doing multi-operation machining. So when that raw material gets loaded onto the carousel, there'll be some work in progress that needs to be moved on to the second op or final op fixtures. So all of this is documented in a digital work instruction, which is also displayed in the RAMTIC kitting software. Those digital work instructions have completely replaced the paper copies of the work instruction on kitting. These work instructions will detail exactly what action and equipment is required for the operation. So it might detail what fixtures are required. For example, what screw do I need to put in this fixture and what do I need to torque it to? So the last part of the kit is actually removing the finished product from the carousel. We have minimal quality checks at kitting. We're only checking threads and a visual check for the cosmetic appearance of the part. That's because we're relying on the process pyramid of the RAMTIC Work Centre, the machine health monitoring, and on-machine probing to guarantee that our parts are dimensionally correct. The finished parts will then leave the kitting station and go on to one of our process finishing work centres. So these include part cleaning, auto deburring to remove any sharp edges or burrs, aquablasting if we're looking for a certain cosmetic appearance or feel to a part, and we also have capabilities in anodizing, vacuum hardening and laser engraving.
I'm here at the Citizen section, which contains 46 machines where we manufacture parts from less than 1 millimetre in diameter up to 32 mil. It's a high volume section and we produce batches of up to 20,000 parts at a time and produce over 5 million parts a year. All our machines feature a second spindle. This allows us to produce components in one machining operation. We feed in a 3-metre bar, machine the component complete and unload the part automatically. This means we can use a low man-to-machine ratio, and typically we have 1 person per 3 machines. To ensure efficient running of the machines are loaded with standard tool packages. This minimises the amount of tool changes we have to do during setups. The sliding head machines typically allow us to make long components with good surface finish that don't require surface grinding or other finishing operations. Processes are designed to remove as many burrs as possible. This means we can limit our subsequent operations after the parts leave the area. As part of our pyramid process, we carry out daily checks on the machines to ensure everything is stable before running our production processes. Most of our processes are replicated across multiple sites. This allows us to maintain production if problems occur.
You join me on one of the areas our team oversees, which is our star sliding head lanes coupled with Renishaw's Equator gauging systems. With 23 tools and 200 part dimensions to consider, setting a part like this on our traditional lathe with traditional setting means such as CMM could take an operator around 2 or 3 shifts to complete. Utilizing Equator, we're now running 1 operator per 6 machines. Set times are also greatly reduced running Equator. These set time reductions are achieved by making a unique setting part that has all the exaggerated features of the final part. Once machined, this is loaded and measured on Equator. Renishaw Central and IPC feedback automatically upload the correct offsets to the machine to move the part towards nominal. Once 2 setting parts have been run, the process is repeated for the final part, with 2 parts being loaded to the Equator and offsets measured and sent via Renishaw Central and IPC. The end result is a fully conforming part with no manual offsets to be required from the operator. On our Equators, we're using the one-to-many feature, which means any parts of any machine can be run on any Equator. This is thanks to the binary dot system our team has developed, where Equator probes the dots and it knows which machine to send the offsets to. As you can see behind me, that means we're only using 4 Equators for our 10 machines.
I'm here in front of the Mazak Integrex i300. It's a mill-turn robot cell, and it's used for the manufacture of our Reza and Rexem rotary encoder rings. The cell itself is capable of running batches of 60 rings and runs approximately between 40 and 60 hours at a time, and it's fully automated. So we're going from a rough billet to a completed, fully inspected ring in one operation. There's no subsequent measurements required. The ring leaves the cell, is polished, and then laser ablated, ready for a dispatch. The tolerances on these rings are a plus or minus 20 microns on the bore and 12 microns on the concentricity. So how do we achieve this? How do we have the confidence that the machine is producing the part correct, and not only correct, consistently correct? We do this following our process pyramid. Process foundation would be the machine itself. The machine has to be correct. We use our ball bar kit, which has got a QC20, and that's a volumetric check to check all the axes are correct. This checks for any wear in any of the axes on the machine. Then we use axis set. Axis set sets up all the parameters within the machine. Once these are set, we can also use our ACS1 unit to set our head length. Once the machine is set up correctly, we can move on to the next stage, which is process setting. Process setting involves an NC4, which is built into the machine, and an RP1 touch trigger probe. Milling and drilling tools are set on the NC4, and then the turning tools are set on the touch trigger probe. Once these offsets are set, we can move on to our next phase, which is in process control. We use the NC4 and the RP1 to monitor tool wear and any breakage, and we also use RMP600 probe to create test cut measures. A test cut measure will be a cut taken in the waste material. This is taken with the same speeds and feeds and depth of cut as the finished cut. This is inspected with the RMP600 probe, and then the offsets are updated. So we have a part that's correct first time. Next, we move on to our verification stage, and this is our final stage, and this will be a full inspection check of the ring to make sure that it's within spec. And we use an RMP600 then to carry out these checks, and all that is de-printed back to the machine. The machine itself has 72 tools in the carousel. Obviously, it doesn't take 72 tools to make a ring, so we utilize this by having sister tooling. With sister tooling, we have identical sets of tools, so when the tool wear is monitoring or is come to end of life, we simply swap out for an identical tool. As you can appreciate, there's a lot of waste when you're producing a ring, so we try to fully utilize that by making smaller rings out of the center of the waste of each billet. The future expansion of the machine shop, we have 4 of these cells on site, 2 of which have been installed within the last year. We're always looking to continuously improve, and Renishaw products help us to do this.
Here at Renishaw, we currently have 2 low-volume production departments at both of our manufacturing sites, here in Miskin and in Stonehouse, which very nearly replicate each other with regard to machines. The general concept of the low-volume department is that we machine high numbers of batches consisting of small quantities of parts. These batches can be as small as 1s, 2s or 5-offs. Due to this, the department constantly experiences a high number of sets, so strive to have as quick a turnaround as possible from the completion of one job to getting the next job running. For a component to be routed through the low-volume department rather than the main machine shop, the annual requirement for the piece part is normally less than 300 parts per year, or depending on complexity, less than 300 machining hours. All customer specials are routed through the low-volume department. Due to these being non-standard Renishaw products, they won't have processes in place for them to run in the high-volume environment of the main machine shop. Due to the nature of low-volume, there is a more traditional method of working. There are far fewer automated processes, unlike RAMTIC. The machine setter operators are in control of their own machining processes. When a new part initially arrives within low volume, the drawing will be vetted by one of the low volume production engineers. This will then get handed onto the machine setter operators, where they will program, set, manually load and unload the components. They are also responsible for their own inspection of the piece parts and creating and designing any fixtures where necessary. The machine type that we currently have the most of is the Mazak Nexus milling machines. We have a count of 21 across both sites. These are very similar to the RAMTIC milling machines, as this is a 3-axis vertical milling machine with a rotating core, allowing the CNC setter operators to program parts at several different angles. The difference between the low volume Mazak machines and the RAMTIC machines is that on our rotating core, we are able to use a vice setup and a wing fixture setup. The vice setup gives us the ability to machine larger individual components, where the wing fixture allows us to make several of the same smaller components at one time. The Mazak Nexus milling machines are able to hold up to 30 tools. We use a standard tool package across these platforms, so 21 out of these 30 tools are the same across all machines. This aids in the reduction of setting time and also programming time. The use of a standard tool package across these work centres helps dramatically reduce set times, as the setter operators need to change less tools and also standardises programming. These machines are also kitted with some of Renishaw's hardware. We've got an NC4 laser tool setter used in conjunction with an automated tool datuming process at the start of each metal cutting program. We also include 2 OMP40 spindle probes in this standard tool package. This is used to quickly set new workpiece datums when setting jobs, and also used frequently in health checks. The DMG Morris are the latest addition to the low volume family. They are very similar to the Mazak Integrex machines, having only a single B-axis head and a main spindle and a post spindle. These have been bought to aid in the manufacture of our larger mill turn parts.
We hope you have enjoyed this insight into our manufacturing operation. If you have any inquiries about anything you've seen, please contact your local sales staff. And of course, product information is available on our website, renishaw.com. Thank you.